Hello everyone and welcome to Ocean Cadence. In this video, today we'll be undertaking the topic of boiler blowdown and the blowdown procedure. That is, why is a boiler blowdown required and what is the procedure to carry it out. So let us start. First, let me address the issue of why is a boiler blowdown required. In a boiler, as we know, we use the fresh water that is being generated on board, or if we receive any fresh water that is being taken from the shore. So now the question arises that when we generate fresh water on board or when we take fresh water from shore facility, we usually test it for all the components. That is, it should not have any salt content, the basic pH value and its hardness and the other factors. So how does it affect the boiler in a way that blowdown is required? Now, first let us understand the basics. Even if we are using fresh water that has zero salt value and other components are in the perfect balance, now when it comes into the boiler system, the water is being circulated in a closed loop. That is, the water is being filled in the cascade tank and then simultaneously being drawn with the help of the feed water pump into the boiler system, that is the auxiliary boiler. Now to simplify things, first of all, I am taking only the example of an auxiliary boiler here because it is easier for us to understand how the system works. So now when this water is in the system, it is being evaporated with the help of the heat that is being produced from the flue products that is generated by the burning of the fuel in the boiler burner. Now, when the steam is generated, we have to maintain the steam in a certain condition. That is, the steam should always be under superheat condition. It should be in a system equilibrium, that it should not cause any corrosion in the form of acidic corrosion or galvanic corrosion in the system inside which it is circulated, and it should not cause any precipitation in the system as well as any other side effects. So now to maintain the water and the steam in such condition, what we are doing is that we are dosing the water before feeding it into the system. This dosing is being carried out in the form of phosphate compounds, hydroxide compounds and other compounds that are being added to the system, such as the carbonate compounds, phosphate compounds and the hydroxides. So now when this dosing occurs, first of all during the evaporation and the subsequent condensation in the condenser system and thereafter the cyclic process, what happens is that a certain amount of precipitation of lighter as well as heavier salts occurs within the steam system where the evaporation is occurring, that is inside the drum. So these salts, whether it may be temporary hardness inducing salts or the permanent hardness inducing ones, that is the lighter salts or the heavier salts, what they do is they separate out from the system and they settle down. Either they settle down or they float up, but basically they get separated from the system. So over the period of time, the concentration of these salts will keep increasing and there would be a point where the concentration would be so much that the deposition of these salts within the system, may it be on the tubes, may it be on the circulation line, or may it be on the boiler furnace or the drum itself, would be so much that it can cause a lot of different unnecessary phenomena such as embrittlement, corrosion, weakening of the tubes and formation of galvanic cell plateaus, which are easy to corrode and easily exposed. So in order to counter these salts that are being generated and deposited in the system, we have to tend towards a procedure where we clear out the water that is now in a saturated condition, that is it has certain amount of salts which is unnecessary, and top up the boiler with another freshwater dosage and add chemicals accordingly so as to maintain the ideal condition of the boiler water. This is where the boiler blowdown comes in place. That is the removal of the existing water that is there in this system and addition of new water subsequently with new chemical dosage so as to maintain the boiler in a healthy condition. Now, there can be other occasions also where salt contamination can occur, such as leaks inside the tubes for the atmospheric condenser, or maybe leak inside the steam lines that are being circulated through the bunker tanks or other big tanks. And these leaks can be in the form of certain cracks or certain contamination in the open system. But however, when we are considering an ideal system, we are negating these leaks and talking only about the salt generation due to other chemical phenomenon during the dosage and all these topics. And also when we are testing the boiler water for salt contamination and salt content and other tests such as the TDS, hardness and other aspects, we can easily get to know that the levels are, whether if they are absolutely high and absolutely beyond the reference point, then they are because of the leak, and when they are controlled yet in such a manner that the level is not up to our satisfaction, it is because of irregular water maintenance of the boiler or imperfect water condition of the boiler. So now that we have known why is a boiler blowdown required, let us now tend towards the topic, how do we carry out this blowdown? First of all, let us consider a water drum boiler. Now we know that the water is filled up to a very high level in order to maintain the equilibrium condition and to make sure that water is always available for evaporation and thereby generation of steam. So the water that is available at the top side of the drum, it will carry out all the lighter suspended solids as well as any oil particles or any other scum particles that are being carried over through the steam generation and the steam circulation network. This oil or this scum content or this lighter salt content again can be because of external contamination or because of internal lack of maintenance or various other reasons that I told you early on. So these lighter units, what they will do is they will separate out, and as a virtue of lesser density and light nature, what they'll do is they'll start floating on the top of the water side. So when we open the scum side blowdown valves, these impurities are blown down and removed from the network. However, the heavier salts, which are more dense and heavier in weight and content, they precipitate and settle down at the bottom of the boiler, and even the heavier suspended solids also settle down here. So by carrying out the bottom blowdown, we remove these heavier contaminants that are settled down at the bottom of the boiler by bottom blowdown. Now the process of this blowdown. As we can see, there are two valves each for scum blowdown and bottom blowdown on the boiler side, and two main valves on the main blowdown side, that is the ship side. Now, while opening these valves, we have to understand that the first valve, that is the number one valve on the ship side, is the non-return valve. That means it will in any condition not allow water to come back from the outside, that is from the sea side into the ship side, therefore making sure that the blowdown is always carried out in a positive manner. The second valve can be a non-return valve or it can be a normal valve if the first valve is a non-return valve. Similarly, on both the bottom and the scum blowdown sides, at least one valve would always be a non-return valve. By doing so, what we make sure is that the blowdown is always carried out in a positive manner. By opening the valves 1 and 2, what we do is that we prepare the line to make sure that at any point of time during the blowdown, the line is not pressurized, because if we open the valve 3, 4 first, either for scum or for bottom blowdown, the water pressure in the line will increase all of a sudden, and any previous condensate that is collected in the line will not have time to drain out, and this will not only cause water hammering, but it will also cause severe vibration and sudden expansion of the line due to high temperature ingress of water. So it can cause the glands to slack, the flanges or the gasket to slip, or even cause a burst in the line due to excessive hammering. So what we do is we open the valve 1 and 2 on the ship side, and also after that we first carry out the scum blowdown by opening the scum blowdown valves. Why we do so is because when the level is high enough and the suspended solids are on the top without any disturbance or without any turbulence, it will be easier for us to carry out the scum blowdown and remove these heavier solids or the oil content that is being collected on the top side. So we carry out the scum blowdown. Then we go down and carry out the bottom blowdown. For carrying out the blowdown, again the process will be the same. First we open the valve number 3 and then the valve number 4, may it be for scum or for the bottom, and by the opening time, that is the amount of time for which these valves are open, we carry out the limitation of the period for how long the blowdown is being carried down. Usually we carry it in a way that the level is maintained just above the alarm level, so as to make sure that the boiler is always being run in a safe condition without any of its system being adversely affected. And while we do so, we also make sure that the cascade tank always has a fresh batch of water sufficiently filled high enough so as to make sure that we immediately replenish the water and maintain the boiler under equilibrium condition. It has to be made sure that when we are carrying the blow down, it should be a repeated process. That is, usually most of the boilers, the bottom or the scum blow down is not just enough to be carried out once when we are doing it. It should be at least 2 to 3 times and for a sufficient period, as I told earlier, to make sure that the solids and the salt content and everything is drawn out sufficiently well. And once we have done that and charged the fresh batch of water, we should allow the circulation of water and the entire steam generation process to occur for some certain amount of time, let's say a batch of 12 to 24 hours, before we carry out the next test to gauge the condition of the boiler feed water as well as the circulation water which is inside the system. Once the blowdown process is carried out sufficiently well, we have to make sure that all the walls are again isolated and the ship side walls are locked and maintained in a way that if any external authority comes on restricted ports, let's say the US where the NPDES is under prosecution, so we have to present it in a way that we have to make sure that no discharge is occurring at the ports under any condition. So by locking the walls on the ship side, we ensure that the key is always with the chief engineer and the condition of the walls is locked down. So it also gives a surety that no blowdown is being carried out at ports. Usually the process of blowdown is always carried out at sea, and it also helps us in a way that by doing so we maintain the freshwater log enough to make sure that if the freshwater consumption is high enough during the boiler blowdown, we can still top it up and have freshwater batches ready for further process. I hope that the video gives you a clear idea of why the blowdown is required and also how we carry out the blowdown and maintain our boiler in a healthy condition, and also make sure that all the test result values are always under limit. Please do like the video if you find it useful. Also subscribe to our channel, share it with your friends and colleagues if you find it helpful, and motivate us for generating such interesting and engaging content further. Thank you so much.